presentation with the series formula. I just want to look at what the reasons give you. And I'm just going to only that one. Okay. They give you that one that I wrote up there. So sometimes you could see this. Do you see how both of these terms, here's the first term in the numerator, here's the second term? Do you see how they both have a sub 1? In some textbooks, that a sub 1 will be factored out, and it will say that. Okay? Which may be useful if you're looking for your first term. Okay? You may have to factor out that a sub 1. But this is the formula the Regents sheet gives you, so we'll use that most often. So, asking you to evaluate, first of all, pretending you don't know this is a geometric day, you want to look. If I'm kind of trying to add up all these terms, I need to first decide, is it arithmetic or geometric? And so you should see the times 6 pattern. So R equals 6. They're asking you to add them all up so you know you're doing a series problem as opposed to a sequence problem. And I put the sequence formula up there. So if we just plug into the series formula, we're looking for the grand total through S sub, how many terms are there? If you know. Do we know how many terms are going to be in this list? No. So leave it S sub n equals, do we know a sub 1? What is it? 2. So that's 2 minus 2 times, do we know R? Do we know R? 6. Do we know to the nth power what n is? No, right? Over 1 minus R, so 1 minus 6. So we have two unknowns. We can't find our series total if we don't know how many terms are here. So what do? We go back to our sequence formula, right? This big maze. So if you go back to your sequence formula, do you know what a sub n is? Do you know what your last term is? Yes, 93,312 is your nth term. I just don't know what n is. Equals a sub 1, which was 2, times R is 6 to the n minus 1 power. So we can use that to solve for its only missing variable n. What do we have to do first? Solving exponential equations. What do we do to solve this? One person said subtract the 2, one person said divide the 2. What do we think? Divide, right, because it's multiplied. So yes, to getting rid of the 2, though, first is critical. So if you divide both sides by 2, 93,312 divided by 2 is 46,656 equals 6 to the n minus 1. I'm trying to solve for a variable that's locked in an exponent. So what do I have to do to get a variable out of the exponent? Yeah. Well, that's where you are, right? That's where I am right now. That answers the question I just posed. You have to use logs, right? Now, log base 6 is probably the easiest because you have a 6. So if I take log base 6 of both sides, that'll just cancel that out. And then I'll just have to add the 1 over. So I'll take the log base 6 of 46,656 first, and then I'll add the 1 over. So remember, under your math, you have log base. So we can do log base 6 of 46,656. Get that number first, and then add 1. 7. So n equals 7. N has to be a whole number, right? If you get that there are 7.3 terms in your list, obviously something is wrong. N stands for the number of terms in a list, so a decimal would never make sense. So we kind of feel good about this has to be right. if we get a whole number. So now we go back and plug that 7 in. So it's s sub 7 equals 2 minus 2 times 6 to the 7th power all over. Can we just make the 1 minus 6 negative 5? And then typing this in, just make sure you do your numerator first, get that answer, and divide by negative 5. So that'll be 2 minus 2 times 6 to the 7th. That's my numerator. I don't necessarily need to record it. Divide that now by negative 5, and I get that my series total through 7 terms is 111974. And geometric series totals typically are very large numbers, okay? Because you're not only does the actual nth term get huge quickly, because you keep multiplying by 6, multiplying by 6, multiply by 6, so the nth term is big enough on its own. Then you're adding it with all the terms prior to it, so they do get big very quickly, okay? So we're just really, the whole usage of the formulas, you know, and knowing to plug what you know into the formulas and go back to the sequence formula if you need to, that's all repetitive. We're really going to try to point out how solving these is different because they're exponential, really is the case. So if we jump to the second one here, we've got, actually let's skip this one for now, we'll come back, because we've got the same type of problem. We know the first term, we know the last term, we can figure out the multiplier, so we'll skip that one because it's going to be very similar to 1. Jump to 3. 3 is different because we're given what we know in exponential format. So in sigma notation format, I should say. Any sigma notation is a series, first of all, not a sequence question. It's a series question because it's asking you to add them all up. So if we go to our series formula, do we know what n is? How many terms are we adding together? 9. Well, if you're plugging in a 1 all the way up to plugging in a 9, you'll have plugged in 9 times. How about a sub 1? How do we find the first term? Plug in 1. So it's negative 2 raised to the, what's 1 minus 1? 0, so raised to the 0th power. What do you think that's going to be? Negative 1. The negative isn't being raised to the 0 power. Just the 2. If they wanted the negative raised to that power as well, they would have put this in parentheses. And they did not. You see that subtle difference? So this can be tricky. That's an exponential tricky thing. But this will be negative 1. So your first term, and I'll just write that, a sub 1 is negative 1. So as far as my formula is concerned, that'll be negative 1 minus negative 1 again for my first term. So I'm here. I plugged in negative 1 minus negative 1 times, do you know your R? What could you do to figure out your R? What's that? Right, start the first couple terms. So now let's find the second term, and then we'll find the third term just so we can see what are we multiplying by every time. So if I plug in 2, it's going to be negative 2 to the 2 minus 1 power, which is to the first. So my next term will be negative 2. And if I plug in a 3, it's going to be negative 2 to the 3 minus 1 power, which will really be the second. That'll be negative 4. Now can you see what the R is? Times 2 times 2. So R equals 2. You could have known that already, though. Isaiah, that's exactly what you should do if you don't know, is find the first couple terms. But why should we have known this? Yep. Well, it's the base of your exponential function, right? The base of your exponent is your common ratio. This is exponential, not linear. the base of that 2 is your common ratio. So, but again, if you don't pick up on that, it's not like you can't find it in another way. Nathan? Because the negative is not being squared. The base of your exponent is just the 2. There's a big difference between this and this. Okay, so in this case, the whole negative 2 is being raised to the power. In this case, just the 2 is being raised to the power, and then it's a negative out in front. Okay? Always a common conversation point when you're dealing with exponents is how important the parenthesis or lack thereof is. So back to my formula. I've got my a sub 1 minus my a sub 1 times my r we just decided was 2 to the nth power. What's n? 9. All over 1 minus our rate of 2. So again, I would do your numerator first and then divide it by -1. So I'm going to do my numerator first. -1 minus parentheses -1 times 2 to the 9th. Probably going to be a fairly large number, 511. And so my answer is -511. Okay? Any questions on that? Yep. Why can't I plug what in the calculator? -2? You can. You can. I'm not going to teach you that way because I find that the regents will find ways to ask it so that you can't do that. And so I just figure from what I've seen on the types of questions that come up like this, the formula has been better, in my opinion. So I don't teach that because I don't want to confuse it. If we jump to this next one, number 1, I know it's geometric because that's exponential, right? What's the ratio? What's the common ratio going to be? What's the base of the exponent? 3. 3 is the base of the exponent. So r is 3. A sub 1 is what? If I plug in 1, 1 minus 1 is 0. What's 3 to the 0 power? 1 times the 4 that's out in front gives you 4. What's n going to be? 9 terms. I'm plugging in 1 through 9. That's 9 terms. And just plugging in that will give us the series total. So S sub 9 equals A sub 1 is 4 minus A sub 1 of 4 times the rate of 3 to the 9th power all over 1 minus 3. And that's just all calculator. Do your numerator and denominator separately. That's just my suggestion to avoid mistakes. So your numerator is -78,728. Your denominator is -2. So when you divide that, you'll get 39,364. Again, don't be alarmed by those large numbers because geometric series and series in general, because you're adding everything together, are big numbers. Your 9th term alone is a humongous number, right? When you raise 3 to the 8th power, that's gigantic. Then you're multiplying by 4, so your 9th term alone is huge. Never mind your series total through 9 terms. Okay? Number 5 gives different information. You're taking -3, and then you're going to subtract 6, then you're going to subtract 12. So, what's A sub 1? -3. What is your ratio? In case, for those of you who can't see it, what we're really doing here is we're taking -3, we're adding -6, then we're adding -12. Do you see that? Right, so it's from -3 to -6 to -12. That's a times 2. So R is 2. N, they tell us, is 9. And I have everything I need. Okay, so Connor, back to your question. If they present it in this way, and you only knew that method, you'd have to kind of write your own sigma notation, which to me is not going to be easy for you, and then use your calculator. This just allows the formula. So S sub 9 equals A sub 1 is negative 3 minus A sub 1 is negative 3 times R's 2 to the 9th power, 1 minus 2. I'm just plugging in what I know to my formula. Try this on your own on your calculator right now. I want to see if we can get the right answer without me walking you through it. Haley Smith, what'd you get? Did anybody get anything different? Good. Okay, so our calculator uses good. And then number 6. The first term they obviously give us. So, and we're looking for the series total. What didn't they give us that the equation needs? N. The equation needs an N, and they didn't give it to us. So how do we find it? Go back to your sequence formula. A sub N equals A sub 1 times R to the N minus 1. I just brought that down. And hopefully we can now find N. Did they tell you A sub N? 320. Did they tell you A sub 1? 5. Did they tell you R? Yes. It's a negative number, so make sure you keep that in parentheses. And then N minus 1. So we have to solve for N by doing what first to both sides, Jake Hutch? Divide by the 5, and you get 64 equals negative 2 to the N minus 1 power. Now do what to both sides? Both. Log base negative 2. Excellent. So on your calculator, log base negative 2 is going to be, I'm going to do the change of base formula, log of 64 divided by log of negative 2. That's going to, ooh boy. Uh-oh. What happened? Log base negative 2 of 64 gives me an error because your base can't be a negative number. You can't take the log of a negative number, and your base can't be a negative number. Lydia? I believe so, but let's wrap our head around why we can do that. So if I go back to the beginning, because I ran into a problem, I got to think about something here. My first term is 5, and my common ratio is 2, negative 2. So if I'm multiplying by negative 2, what's my next term? Negative 10. What's my next term? Positive 20. And then negative 40. And then 80, dot, dot, dot. So every other term is going to be positive anyway. Yes? So we can sort of ignore that negative and just take log base 2 of 64. And what do we get? 6. So because, so 6 equals n minus 1. And then when you add 1 to both sides, this is 7 terms. Because every odd term, the first, the third, the fifth, and the 7th, are all going to be positive anyway. So this, we find out that n is actually our 7th term. And then we can use the series formula, Isaiah. Only because it's like every other term. Yes, as long as you kind of go back and kind of make sense of that, there's some little troubleshooting and thought that has to go into that. Okay, so I'm going to give you your homework. Yes. You can because of that every other. When your common ratio is negative, every other term is going to be a negative, positive, negative, positive, negative, positive. We didn't get to the word problems, but again, you're just reading them and extracting